Hello, it's David. Now this old Compaq VGA monitor is one that I normally have hanging on my wall, and you'll have seen possibly in previous videos that it started acting up. What would happen is that it was acting as if the menu button was being pressed all of the time, and then eventually it locked out the on-screen display entirely because it thought I was fiddling with it or had activated a child lock or something. Anyway, it's misbehaving. So I've taken it down off the wall, taken the ISO fixing off, and I think we better crack this open and have a little bit of a look and see if we can figure out what's going wrong. My suspicion is, as with all monitors and with most things in general that run hot, that the power supply capacitors have probably dried out and have lost their rating. So let's see if we can get in here, find the power supply and have a look at those caps, see what we can do about it. There are two screws here, normally for the stand that goes in the bottom. It's only got one screw in at the moment, so it looks like it's lost one. And there are two in the bottom corner here, which I've taken off. I can't see anything else on the back here. Nothing underneath. Nor on the top. So I suspect this is one of the ones where actually most of the work is trying to pop a bezel off the front. Although I can't see that, obviously. A couple of tabs here that look like likely candidates. Need a spudger. There we go, I think that's all the clips out. I think face down. Okay, there we go. Shell just comes away. Ooh. Where did that come from? Just hidden away in there, there's a little screw, I think. How the hell are you meant to get into that? Oh, don't tell me you've got to take the power socket off to reach the screw. I wonder if I can just get a little... sneak a little electrician screwdriver in there, maybe. Oh, they don't make it easy, do they? Okay, so this is pretty much going to be power supply and logic board, I think. So it looks like we've got the back lighting, I would imagine, going in here. There's a cross bus here. I'm going to be a bit careful with that cap there. Okay. I haven't turned this on actually for weeks, so I doubt it's charged up. Right, so we've got a few capacitors on here to have a look at. Quite a few actually. 1, 2, 3, 4, 5, 6, 7, 8, 9... 10 electrolytics at least. Mind you, I can't see, is that one down there as well? Yeah. I can't see any obvious signs of failure, but we can certainly start with the big one and maybe take a measurement or two. No, nothing looks bad there. It's just got a little, this looks a little grotty. I suppose I could give it a clean just in case there's any sort of low impedance pathway there. But for me, to be fair, I've seen a lot worse in terms of capacitors in monitor power supplies. I suppose it's entirely feasible that it's nothing to do with the power supply at all, and it's just the logic board for the front panel. I wonder if it's possible to power this up and measure the actual output. Or shall I just take out that big capacitor anyway and do a measurement on it? I think since we've come this far, that would seem to be the sensible solution. Okay, I think we need the desoldering station out. Okay, so the desoldering station has been out, and I've got that off in short order. Makes a terrible noise, so I haven't put it on. But they came out. They came out straight away, and to be honest, the capacitor looks in pretty good nick. Perhaps there's just a little bit of muck on these legs, but I wouldn't even call it corrosion. So we'll use my cheap Chinese tester here. So try and jam. I think you can do a pin 1 to 2 or pin 1 to 3. You see it says on there, it says 1 2 3 1 1 1 1 1. So let's try and jam that in there. And well, hopefully this gives us a bad reading. As if it doesn't, it means it's probably something else. This is the capacitor most likely to do the heavy lifting. Okay, there we go. Can you see that? That says, it's very difficult. There we go. That says that it's reading 92 microfarads, I think it's 100, and it's got an ESR of 0.44 ohms, which is, to be honest, fine. So there we go. Yeah, 100 microfarad, 400 volt cap. So actually, I think that cap is fine. So, given how, to be honest, clean this board looks, can't see any obvious heat damage anywhere. Maybe there's a little bit of discolouring here, but it's very, very light. So given how that looks, and the fact that probably the capacitor doing the most lifting is measuring fine, we might have to change tack here. I think I shall resolder that, and what we might need to do is to get it back into the monitor and power it up, and do some voltage measurements. It could very well be that it's not actually this board's fault.
I'd like to thank this video's sponsor and the supplier of my project PCBs, PCBWay. PCBWay aren't just about PCBs either, although they are extremely good at that. They also offer component assembly, CNC machining, 3D printing, and a variety of other manufacturing services. They have a number of community-focused offerings too. The Shared Project Hub is an open platform for makers to share and exchange their ideas, and the PCBWay store is a great place to pick up assembled modules. I mean, who wouldn't want a musical Tesla coil? So many thanks again to PCBWay, and I recommend you have a look at some of the links included down below.
Okay, so I think first of all I'm going to do some probing just to see what voltages we actually have coming off this this board before we connect it back up. There's no point scoping it, I don't think, because well, one, I don't want to block the scope if one of these is really high voltage, but also it won't be under load, so that's a bit pointless. So what we'll do is we'll flip it over, we'll get it powered up, and then we'll measure this header. I think this is the header that goes off to the logic board over here, and our thing that was failing was down here. We may take this out before we go too much further and just make sure that this board at the bottom, which is actually the one holding the panels, doesn't have, you know, just a physical failure. Like, it's not that the button is just shorted out or something. But whilst we've got this board out, we might as well measure some voltages. So the easiest way to do that is flip it over that way. This plugs in like that. So we're not, you can see the power lead's going, don't worry, it's not plugged in. So that plugs in that way. I'm just going to flip it over there and put it on the on that insulating bit of cardboard there, and we will bring in our meter, and this is our area of interest down here. So let's power that up and see what's what. Okay, the power's on, so we should have 240 volts running into this, so I'm going to try and be a little bit careful. And I don't actually know where ground is on this board. Just for inspection, this hole here appears to be attached to this plate, so maybe this is ground. So let's just try measuring across this capacitor. Nothing. I want to stay away from the high voltage side. I presume that's what this dividing line is down here. This would be the primary side. This is the sort of not the primary. This is the high voltage side. This should, I would have thought, be the logic level side. There's an awful lot of flood fill here. I don't know whether that would be ground. I don't want to short anything accidentally. Okay, -5, 7.8, -2.5, -2.5, -1.7, negatives, -1.7. I don't want to get too close to this primary side here. -5, -5. Perhaps I'm probing the 5 volt line. Yeah, I might be, what I think is ground might very well be the 5 volt line, and therefore I'm getting -5 on others. So perhaps if I choose pin 1 there as my ground, or as my negative reference, what do I see then? .6, 2.5, 3.6, 0.3. 5 volts. Right, so my guess is that these end ones are the ground. Mind you, that 0.3 was a funny measurement, wasn't it? That's maybe the 3.3, well, 2.5. Ground again at the end. Okay, so this is what I come up with. They are paired, so we've got ground, then we've got 5 volts, then we've got ground, then we've got 3.3 volts, then we've got 2.5 volts, and then we've got another ground. And as I say, they're paired, so the forward and back are the same. I need to hold the probe on for a bit of time for it to stabilize, but actually the regulation is pretty good with no load. I'm starting to think perhaps it's not power supply after all, and maybe we ought to investigate the actual physical switches before we get the soldering iron out and start connecting extension lines to this so that we can monitor it in situ. Okay, so this is the front panel circuit board here. I've just got the front popped up here, so I'll press the buttons underneath. That's switch 1, that's the main power switch. We've got switch 3, switch 4 and switch 2 here. And I don't think it was the power switch that was a problem. We've got continuity mode on here. Nothing doing open circuit there across the main power switch. Let me see if I can press the button at the same time. Oh, that was me pressing the button by leaning on it. So, there we go. Can you just see that? There we are, yeah. Beep when my thumb presses the button. Okay, so let's try switch 3. Okay, so the problem we were seeing was that it kept complaining that switches were being pressed when they weren't. Maybe there's a passing contact. Oh, I might just be no, I don't know. Maybe they are passing contact. I can see just off screen that they're not. I'll get this in on shot. You see something happens when I press the button, but it doesn't go straight to 0 ohms. It goes down to 180 ohms. But anyway, that doesn't look like it's persistently stuck closed. Switch 4. No, so that's not. That's reading as open loop. That works better. Maybe switch 3 just needs a bit of a clean. Switch 2. Open loop. Well, none of them are great, are they? But they're not all stuck closed or something like that. Hum. Okay, so I'm going to reflow, I think, all of these switches. So we've got 4 different switches here, and I'm going to give it a reflow and a proper clean up. I don't like the look of this joint in particular, but say this is the main power switch. I don't believe this is the problem, but I don't think there's any harm, is there? Now, to be honest, what I'm probably not quite doing correctly here is I probably ought to be removing the solder rather than just adding extra, because the chances are this solder is non-leaded solder and I'm using leaded, and the two together are probably not the best long-term combination. But given this monitor is really quite ancient and seems to be on its way out anyway, life is too short. I just want to try and resolve the problem for now. If I have to revisit it later, at least I'll have an idea of what the problem is if I see it again. Okay, well, that's our 1, 2, 3, 4 switches. Let's give that a clean up and we'll move on to a bit of a test. Right, so connected up here. Got the power lead in the back. The back case is off, obviously. It's upside down. Power lead in the back. The VGA is going into my Windows box under here, and the power lead is here. So if anything goes pop, I'll whip it out a bit quickly. So I'm going to connect it up now. Okay, nothing has exploded. We've got a flash. Let me try powering up. Okay, green, it's gone green, and we have a signal. Okay, good, it's adjusting. It's massively the wrong resolution. I don't know if you can see that on there. It is showing something. It is completely the wrong resolution because it's obviously scaled for a different monitor. This is just being paralleled here. And we had a red stripe down the middle, but to be fair, there's something wrong, something separate. Ah, here we go, on-screen display locked. What I was saying about that red line is that that's a separate issue. That I've had that for a long time, and it's when it warms up, it tends to resolve itself. But here we go. This is the real problem. This is the problem we're seeing. OSD locked, and then it's as if buttons are being pressed. That's the on-screen display locking, because I think it assumes that I've held down a button or something. Right, there we go. You can see that there is now actually a valid picture on there. The picture's not the problem. Let's try and press menu. Nothing. Let's try and press the auto calibration button. Nothing. So that hasn't really helped us at all. It might be time to start measuring those voltages. Okay, so I now need to be very careful because we are going to be dealing with mains voltages exposed here. So no dangling clothes. I've suspended the buttons area down here so that there's nothing just being pressed on. And let's try firing it up. It's going to be very difficult to actually see whether there's any. Okay, I can just see through the circuit board, you probably can't from that angle, that there is an LED illuminating under there. So that's off. Press it once, it goes orange and then goes green. Okay, so we are actually up and running. So according to my list, I think the nearest one to us here is ground, and then it should be 5 volts. So I'm going to try measuring from the chassis there to the 5, what I believe to be the 5 volt pin. It's going to be quite awkward to do this. Let's do it this way around. And that's the main section. I'm just going to try touching this and see whether this is suitably conductive. There we go, 5.1. So that's the 5 volt rail. Seems quite stable. Then it'd be ground, then it'd be 3 volts 3. Yep, then it will be 2.5. Yep, and then another ground. So those look stable. Okay, well, I am starting to run out of ideas now because those voltages do look very, very stable. They don't appear to be particularly, you know, if they were pulsing, I wouldn't expect them to average that close to being correct. Last resort, we'll get the oscilloscope out, but it seems a lot of faff if we can fix the problem by observation. Okay, so I've dug out the manual from archive.org, and the manual doesn't tell us anything. It doesn't even mention the on-screen display lock. But searching around on Google, the HP knowledge base here on screen tells us that the on-screen display lock can be enabled or disabled by pressing and holding the menu button on the front for 10 seconds. So if there is anything malfunctioning, it's this menu button here. So I'm going to hold it for 10 seconds and we'll see how we go. That's the 10 seconds. Maybe we'll do some more continuity checks. Well, this is interesting. It could just be that there's a capacitor across the circuit there charging up. But look at the resistance across this this menu button. If I press the button, it drops down to, well, wobbly. It's not great, is it? And if I release it, it goes up to a kilo ohm and 700, 600, 5. It keeps. Oh, is this a problem? Perhaps I should just remove the switch. What's that hiding down at the bottom of one of my enormous jars of bits and bobs? That to me looks like tactile switches. Let's get one out and see if it fits. Okay, so switch 2 here is our switch of interest, and as you can see, it's a 5-pin arrangement. It's got 2 pins on the top side, 2 on the bottom side, and also a strap that goes over the top. This tactile switch I've got here does not have that strap pin, but I don't think that's required, because if you look at the flood fill here, these 3 are clearly all connected, so I think we can do without that. In fact, looking at switch 1 over here, that does have a missing pad, doesn't it? That's the one that we thought there'd been worked on before. I think perhaps it had already had a replacement, so these switches perhaps are a bit dodgy. So to me, that looks like it's going to fit. So let's fire up the desoldering station. Let's have this board out and get one of these switches substituted. Okay, let's get our flux on here. Just a little bit of liquid flux. I don't think we're going to need too much to get this off. Famous last words. How does that look? Not bad. Straight out, lovely job. Right, so this one should hopefully just pop back in here, pretty much like for like. Here we go. Perfect. Good enough, I think. Clean it up. Let's get it back in. Okay, so just a quick test before we put everything back. This is wired across the same, and you'll notice straight away that we're not showing 10K anymore. We're now showing open loop. When I press the button, perfect, and release, open loop. So that's quite interesting. This switch is obviously behaving differently. It's not extra capacitance or another resistor somewhere. I think we did just genuinely have a failing switch. Alright, so we just props up again with the back off. I'm plugging in the power now. Green, orange, green. There we go. Look at that. Perfect. There's our Windows machine. Right, let's press the button. Oh. Look at that. So, the lesson from this, read the manual. Okay, so let's have a look at the fruits of our labour. We've got the Falcon plugged in. It's a very nicely functioning VGA screen. Let's see what we can do with it. Excellent. So the moral of this story is, well, sometimes the simplest solution is the right one. And I think the result is definitely a double thumbs up. Even he agrees. See you next time.